Hello everyone, welcome all to my channel. Those who are new to this channel, myself Sai Krishna, studying in 9th grade. This is my YouTube channel. Okay, in today's video we will learn reciprocal functions of trigonometric ratios and the next topic. Okay, firstly reciprocal functions of sine, cos, tan, cosecant, secant and all. Okay. Firstly, let us write the reciprocal ratio for tan. Tan theta is equals to sin theta by cos theta. The reciprocal ratio of tan is cot. We already know that. So, now let us write cot. Cot theta is equals to the reciprocal ratio. It is cos by sin. Cos theta by sin theta. The next one is sin. Sin theta. Sin theta is equals to, what's the reciprocal ratio of it? Cosecant. So 1 by cosecant theta. The reciprocal ratio of cosecant theta is sin. So cosecant theta is equals to 1 by sin theta. Next one is, this can be written as sin theta into cosecant theta is equals to 1. When the denominator is dividing, when it moves to the other side, it becomes multiplication. So sin theta into cos theta is equals to 1. 1 will be remained here. Okay. The next one is cos theta. The reciprocal ratio of cos is secant theta. 1 by secant theta. And the reciprocal ratio of secant is cos theta. So 1 by cos theta. This can be also written as cos theta into secant theta is equals to 1. Is equals to 1. Next we are left with tan theta. Tan theta is equals to 1 by cot theta. The next one is the 10th one. Cot theta is equals to 1 by tan theta. Cot theta into tan theta is equals to 1. Okay. These are the 11 reciprocal functions, and we must remind and must always keep in mind these 11. These will be helpful in doing sums. Okay, first one, let us recall them. Tan theta is equals to sin by cos theta. The reciprocal ratio of tan is cot, and tan theta is equals to sin by theta. The reciprocal is cos by sin theta. Next one is sin theta. Sin theta is equals to what's the reciprocal ratio? Yes, 1 by cosecant theta. Cosecant theta is equals to 1 by sin theta. This can be written as sin theta into cosecant theta is equals to 1, and cos theta is equals to 1 by secant theta. Secant theta is equals to 1 by cos theta. This can be written as like this, and tan theta is equals to 1 by cot theta. Cot theta is equals to 1 by tan theta, and cot theta is into tan theta is equals to 1. Okay, let us move to the next one. That is trigonometric identities. Okay, now let us learn trigonometric identities. Trigonometric identities. Next one is trigonometric identities. There are 3 identities. Now we are going to learn that. Okay. As we said, there are 3 identities, and firstly let us write the definition for the trigonometric identities. Okay, let us write an equation which involves in the trigonometric ratios which is valid for all values of the angle. For all values of the angle for which the ratios are defined. This is known as trigonometric identities. This is known as trigonometric identities. It is an equation which involves in the trigonometric ratios such as sin theta, cos theta and all, which is valid for all the values of the angle. If we take an angle, this trigonometric identity is valid for all the angles. For which ratios are defined. Okay, let us start the first identity. Okay, first I am considering a triangle with 90 degrees angle, and this side is considered as theta A, B, C. A, B, C. Opposite to theta is opposite side, adjacent side. This one is the longest side, that is hypotenuse. Okay. The first one is first identity. Sin square theta plus cos square theta is equals to 1, where theta belongs to real numbers. Okay, we need to prove this one. We need to prove sin square theta plus cos square theta, which is equals to 1, and here theta is belongs to real numbers. Okay, firstly we all know that Pythagoras theorem. That Pythagoras theorem is theorem. Pythagoras theorem is equals to opposite side whole square plus adjacent side whole square, which is equals to hypotenuse whole square. Okay, we are going to deal with this formula. Okay, this can be written as opposite side whole square divided by hypotenuse plus hypotenuse whole square plus adjacent side whole square by hypotenuse. We wrote this one as like this. This can be written as like this. Okay. Here we have got denominator and numerator squares, so we can write it as whole. Opposite side by hypotenuse whole square plus adjacent side by hypotenuse whole square is equals to 1. What is opposite side by hypotenuse? Opposite side by hypotenuse is sin theta. We all know that opposite side by hypotenuse is sin theta. So sin square theta plus adjacent side by hypotenuse is cos theta. So whole square. So we can write cos square theta is equals to 1. Hence proved sin square theta plus cos square theta is equals to 1. Okay, we can write this formula in many ways. So we will write that in other ways. So sin square theta, when it moves to that side it becomes minus, so 1 minus cos square theta. Okay, now sin theta, the square, when it moves to another side it becomes root, so we don't know whether it is plus or minus, so plus or minus sin theta is equals to plus or minus 1 minus cos square theta. 1 minus cos square theta. And we can also write cos square theta is equals to 1 minus sin square theta. And in the same way, cos theta is equals to root over 1 minus sin square theta. Okay? Root over 1 minus sin square theta. This is the first identity. The next one is, we will learn the next one. Second one is 1 plus tan square theta is equals to secant square theta. Second identity is 1 plus tan square theta is equals to secant square theta. Okay, here theta belongs to here theta belongs to 2n plus 1. N is the constant or something into pi by z into pi by 2, where here n belongs to integer. As I said before, n is a constant, so n belongs to integers. 1 plus tan square theta is equals to secant square theta. Theta always belongs to, in this identity always theta belongs to 2n plus 1 into pi by 2, where n belongs to integers. Okay, now let us prove the identity. Again, by Pythagoras theorem. Opposite side whole square plus adjacent side whole square is equals to hypotenuse whole square. By Pythagoras theorem, opposite side square is equals to adjacent side whole square is equals to hypotenuse whole square. Okay, let us assume this whole equation as 1. Okay, let us assume this whole equation as 1. Now we need to divide 1 by adjacent side square. Now divide equation 1 by adjacent side whole square. Okay, now we need to divide the equation by adjacent side whole square. Okay, opposite side whole square by adjacent side whole square. Whole equation we need to divide by adjacent side plus adjacent side square by adjacent side square get cancels and it becomes 1, that is equals to hypotenuse whole square by adjacent side whole square. Okay, adjacent side whole square. Opposite, this can be written as opposite side by adjacent side whole square plus 1 is equals to hypotenuse by adjacent whole square. Hypotenuse by adjacent whole square. Okay. Now opposite side by adjacent side plus 1 is equals to hypotenuse by adjacent side whole square. Okay. We know the ratio of opposite side by adjacent side is tan. So we can write tan square theta plus 1 is equals to hypotenuse by adjacent side is secant. So secant square theta. Okay. Hence it is also proved. We can write tan square theta plus 1 or 1 plus tan square theta. 2 plus 3 and 3 plus 2 is same. We know already we know that. And it can be written in other forms. Let us write them also. Okay. Okay, we will write the formula in the other forms. First one is secant square theta minus tan square theta is equals to, when this tan square theta moves to that side, it becomes minus, and secant square theta minus tan square theta is equals to 1, and we can write it as in the other form secant theta is equals to 1 plus secant square theta is equals to 1 plus tan square theta. The next one is secant theta is equals to root over 1 plus tan square theta, root over 1 plus tan square theta. Next, tan square theta is equals to tan square theta is equals to, when this moves to that side, secant square theta minus 1. Okay. Tan theta is equals to root over secant square theta minus 1. Okay. Can we write it in other forms? Yes, we are done. And what can be further written here? We can rewrite it as secant theta plus tan theta into secant theta plus tan theta into secant theta minus tan theta. Secant theta minus tan theta, that is equals to 1. Okay, a square minus b square is equals to a plus b into a minus b. You all know that. And the next one is, sorry, always confusing with blue and black. Remind it. Okay, secant theta plus tan theta is equals to 1 by secant theta minus tan theta. When it is in the multiplication form, and when it moves to that side, it becomes divided by minus tan theta is equals to 1 by secant theta plus tan theta. Secant theta minus tan theta is equals to 1 by secant theta. Okay, then it moves to that side, becomes Okay. Let us move to the third identity. Okay, let us move to the third one. 1 plus cot theta is equals to cosecant square theta. 1 plus cot theta is equals to cosecant square theta. Here theta does not equal to or does not belong to anything. N is a integer and belongs to integer. Okay, theta does not belong to nx. N is an integer. Yeah. Okay, let us again write the Pythagoras theorem. Opposite side whole square plus adjacent side whole square is equals to hypotenuse whole square. Let us assume this equation as 1 and now we need to divide the whole equation 1 with opposite side whole square. Divide the equation. Now divide the whole equation with hypotenuse whole square. Okay. Opposite side whole square by adjacent hypotenuse whole square plus adjacent side whole square by hypotenuse whole square is equals to hypotenuse whole square by hypotenuse whole square. This gets totally cancelled. Okay, opposite side by hypotenuse. Opposite side by hypotenuse. Okay, let us write opposite side by hypotenuse whole square, adjacent side by hypotenuse is equals to 1. Okay. Opposite side by hypotenuse whole square plus adjacent side by hypotenuse whole square is equals to 1. Okay. I think we have done a mistake somewhere. Where yes. Sorry. We must divide it with. I have a little bit of confusion and confused. So we must divide with opposite side whole square. Opposite side whole square. We must divide the equation 1 with opposite side whole square. So opposite side by opposite side whole square. This totally gets cancelled and remains 1 here plus adjacent side by opposite whole square is equals to hypotenuse by opposite side whole square. Okay, what remains here? 1 plus adjacent side by hypotenuse is cot. Okay, cot square theta, because here it is square whole square, so hypotenuse by opposite side is cosecant, which is the reciprocal ratio of sine. Cosecant square theta. Hence this is also proved. This is 1 plus cot is cot square theta, not 1 plus cot theta. Okay, hence it is also proved. Okay, let us learn the remaining forms of this. It can be written as okay. The other forms, cosecant square theta is equals to cosecant square theta. When it moves to that side, cot square theta is equals to 1. Okay, the next one is cosecant theta is equals to cosecant square theta is equals to 1 plus cot square theta. Cosecant theta is equals to root over 1 plus cot square theta. The next one is cot square theta is equals to cosecant square theta minus 1. Cot theta is equals to root over cosecant square theta minus 1. Cosecant square theta minus 1. As we written in the previous one, it can be written as, this one can be written as a square minus b square is a plus b into a minus b. So cosecant theta into a plus b, cot theta into cosecant theta minus cot theta, that is equals to 1. We can write okay. The next one is cosecant theta minus cot theta is equals to 1 by cosecant theta plus cot theta. Okay, this is the third identity and we have completed the 3 identities, and in the next video we will learn the further topics. Okay, I think in 2 more videos we are going to complete the concept and we are going to start the integrated problems. Okay, thank you for watching the video. Please like, share and subscribe, which boosts me to do further videos. Okay, stay home, stay safe. Thank you. Bye all. Okay, who are new to this video, this is the book which I will prepare for everything. Okay, bye all.